Welcome to Health Matters, a global virtual conference. So we're going to make a shift from nutrition into something else, and that something else is technology. And I don't know about you, but I enjoy using and I would say probably love learning about new technology. If you're similar to me, I think you're going to find this panel discussion very interesting and insightful. I think it's going to be very intriguing to look at how technology is changing rehabilitation. So we have panelists, and I'm going to turn this over as the moderator to Swathi.
Thank you, and hello. I'm Swathi Kiran. I'm a professor at Sargent College in the Department of Speech and Hearing Sciences, and I'm going to be the moderator of this panel on how technology is changing rehabilitation. My panelists today are Professor Frank Guenther, Professor Kevin Berner, and Professor Terry Ellis, and I'm going to ask them to introduce themselves a little now.
My name's Frank Guenther. I'm a professor of speech, language, and hearing sciences and biomedical engineering at Boston University. My areas of expertise are speech neuroscience and the development of brain-machine interfaces for people who are suffering from locked-in syndrome, which is a condition characterized by complete paralysis of voluntary movement with intact cognition and sensation.
Great. Thank you. My name is Kevin Berner. I'm an occupational therapist and certified assistive technology professional. I am an adjunct instructor here at Sargent College, and I practice in the Boston area. My areas of interest include neurologic rehabilitation and using assistive technology to help individuals meet their personal and occupational goals.
Hello, my name is Terry Ellis, and I'm an assistant professor in the Department of Physical Therapy and Athletic Training. I also direct our Center for Neuro-Rehab here at Sargent College. And my experience with technology is in using technology to try to reach people in their homes and communities, specifically to enable them to access and sustain exercise over the long term.
Okay, thank you all for being here, and we have many people watching us from all over the world, so let's jump right into this discussion. For all of you, in your opinion, how has technology changed rehabilitation? In other words, what is the technology approach able to do now that we could not do before? Frank, let's start with you.
Okay, well, the technology that I work with is brain-machine interface technology, and this is something that's been developed over the past decade to work with people who are profoundly paralyzed, so people who are quadriplegic or locked in. And the technology involves implants in the brain that are placed in motor areas of the brain, so the parts of the brain that control movement. And the systems decode the brain signals into commands that they can use to drive an external device, such as a computer or a robotic arm, or in our case, a speech synthesizer. These technologies are currently limited to laboratory use, but there have been some really amazing developments over the past 10 years and demonstrations, for example, of control of robotic arms by people who are completely paralyzed and are then able to give themselves drinks of water, for example, and the control of a speech synthesizer to produce some rudimentary speech by a person who was completely locked in and had no other means of communication. So the brain-machine interface technology is really about to revolutionize the way paralyzed people are able to become more capable and to restore really some really basic capacities that they're missing. In the case of locked-in syndrome, probably the worst aspect of the disorder is the lack of communication capabilities. So the promise of this technology to restore the ability to have conversations with family and caretakers is really an exciting new development that's happened pretty much in the past 10 years.
Fascinating. Kevin.
Great. So one of the most noticeable trends in rehabilitation is that individuals who are therapists have less opportunity to spend quality time with their patients. This is happening because of shorter lengths of stay, because tighter productivity benchmarks, and because there's increased demands for justifying care. Another development that we've seen in the literature is that there are some really positive rehabilitation outcomes seen for individuals with chronic neurologic impairments. This requires high dosage and high frequency of high intensity rehabilitation. Unfortunately, these two things do not add up, and there is a disconnect between what we're seeing in the literature and what's happening in the areas of practice. Rehabilitation robotics provides an opportunity for increasing the amount of quality time individuals are able to participate in home programs while continuing to provide the same level of intensive and high quality care in the clinic.
Thank you. That was really interesting. Terry.
So I'll give you an example from people with Parkinson's disease, for example. So people with Parkinson's disease, particularly in the middle to later stages, often experience fluctuations in status. So the medications are working for a while, and then they're not working, and someone with Parkinson's disease can go from being able to move to not being able to move, and their symptoms drastically change. So there have been tremendous advances in technology that allow us to monitor the symptoms people experience from Parkinson's disease in the home and community environment. So we can get much more information about what's going on. Instead of relying on the patient coming to the physician's office or coming to see this physical therapist and sort of relying on recall to talk about their experiences in the home environment, we can actually look at data. They can wear sensors, and we're able to look at the data and see, how has their symptoms been changing over time? How is their activity level changing over time, for example? And that kind of information makes it easier for us to treat them and individualize the treatment to best meet their needs. So that's on the assessment end of things. There's lots of advances in technology that allow us to be more refined in our assessment. The other area that's exploding is, how to use technology to better deliver treatment in the home environment. So some of the things we're doing with people with Parkinson's disease is trying to figure out, well, how can they access exercise from their home? So we use an application that I talked about earlier today, in which we videotape patients performing their exercises. This can be accessed through an app or an application on their smartphone or tablet, so they can access these exercises from anywhere at any time. And the beauty of this is that an exercise program, once prescribed, needs to be adjusted over time as the patient's status changes. So in this particular example, we can remotely change the exercises without having to have the patients come in. We can just look at their data, see how they're doing, and make adjustments to their exercises in real time. It's fascinating.
Thank you. So this next question is for Kevin and Terry, and it's actually a follow-up to what both of you just talked about. In your opinion, what do you think will be the role of the clinician in this ever-evolving landscape of technology? Kevin.
Thank you, Swathi. I see the clinician has an opportunity to do the same great things that they're currently doing right now. They will see a patient in the hospital, the clinic, or in the home. They will perform a thorough assessment. They will come up with an innovative treatment plan. They will be able to execute some great hands-on therapy, but there are additional opportunities that can happen. Instead of doing a home exercise program on a piece of paper, they may be able to prescribe or train the individual in doing an exercise program with some sort of technological device. This would increase the opportunities for individuals who require physical assistance to perform some of these activities or exercises. For example, if somebody has had a stroke or a brain injury and is not able to perform the movements without physical assistance, they could perform these movements with the rehabilitation robotic device either in the clinic outside of therapy or in the home. There might be some opportunities for the therapist to interact with the person and modify the program. Maybe they can monitor and see how the program is going through feedback from the device.
Interesting.
Mm-hmm. Yeah, I think, clinicians are often challenged by the limited number of visits we get to spend with patients. So third-party payers often limit the number of sessions that patients can see their various therapists. So this is using technology. It's an opportunity for clinicians to to sort of spread out the treatment over a longer period of time or supplement the treatment that they're able to provide in a clinical setting. So you can sort of have that connectivity, you can maintain a connection over time. So instead of seeing rehabilitation as sort of one episode of care that has a discrete beginning and a discrete end, we can think about how do we keep connected with that patient and deliver care over a longer period of time. We can do it more remotely and do it in such a way that allows the patient to access the benefits of rehabilitation from their home and community environments.
Great. So as the audience has now figured out, there are quite a few varied technological applications here. And so let's get into the techno part of this a little bit. And this question is for Frank and for Terry. What is that innovation in that technology that you're part of that is allowing this infusion into changing rehabilitation?
Well, for our work, there are two really key things that have occurred over the past 10 to 20 years. The first thing is that people have developed systems that consist of electrodes that can be permanently implanted into the brain or implanted for long periods of time that can collect signals from a large number of neurons. And this information is very rapidly transmitted to a computer where people can operate on these signals with algorithms that look to decode the information that's in there. So, for example, if somebody's trying to speak, our goal is really to collect enough information from the part of the brain that controls speech that we can decode their intention. What are they trying to say? And that leads into the second real innovation in the past 10 or 15 years, and that's our understanding of how the brain controls movements, and in the case of the technology we work with, how the brain controls speech in particular. One of the things that is limiting for brain-computer interfaces is that we're only recording from a small number of neurons compared to the total number of neurons involved in a brain system. So the parts of the brain that control speech consist of tens of millions, hundreds of millions of neurons working together, but a brain-computer interface can only pull out information from maybe 100 neurons at a time. And so we need efficient algorithms that are aimed at decoding the information that's in those neurons, and that's very specific to the part of the brain that's been implanted. So, for example, if the part of the brain that controls speech movements, so movements of your tongue and lips, is implanted, it's very difficult, it's impossible, in fact, to try to decode all the positions of the tongue and the lips during this, but it turns out we're able to decode the intended sound signal that the person is trying to make, and because we're able to do that, we can route that information to a speech synthesizer in very short period of time, in about 50 milliseconds or 1/20th of a second, and then that sound is played over a speaker to the individual, and so they can hear what the system thinks they're trying to say. And the fact that they can hear it in real time is very important because it allows their brain to learn to control the system better and better. Because we have such a small number of neurons, it's impossible to fully decode what somebody's trying to say. You make really your best guess based on your decoding algorithm. You play that sound, but the user gets used to using this system and gets better and better at producing sounds with the synthesizer in a way that more or less replaces their paralyzed vocal tract. So really the development of the electrode technology combined with the development of a better understanding of the brain and speech are key developments that have occurred and made this possible.
Well, that sounds like science fiction to me. And if you're watching and if you have questions, please post them on Twitter for Frank, but more about the technology. Terry?
So in the work that I do, I think the biggest change that we've seen is the explosion in the availability of smartphones and tablets, and how they've been infused in people's lives and are so commonplace. And then the technology that are in the smartphones, such as accelerometers, for instance, I mean, many people can monitor their physical activity, for example, just on their cell phone. How much did you walk today? How many steps did you climb? And, you know, that kind of real-time feedback presented beautifully in some graphic, visual manner provides, you know, lots of feedback and motivation for people to monitor their physical activity and actually do something about it. we've even found, I mean, we work with people with Parkinson's disease, so an older population typically in their 60s, 70s, 80s, and we have found that they are, even though they might not be sort of usual users of this technology, they are very interested and very successful in using the technology because it's so simple. A simple swipe, and the data comes right up. So, and I also think these things have gotten a lot smaller over time. So we're able to, people can wear something simple on their belt or some body-worn sensor that we can monitor. Physical activity or changes in tremor or changes in dyskinesia very easily in such a way that people are willing to wear these things.
Very interesting. So that leads me to my next question, because I think, Terry, what you're saying is that the patient is sort of now in the center. And for all three of you now, what is, in your opinion, going to be the role of the patient in each of these technological landscapes that you're involved in? Frank, let's start with you.
Well, in the near term, the technology that we are working with is really a laboratory technology, and what is absolutely crucial to the process is that there are patients who are willing to participate in this sorts of research programs that are looking into these devices and developing these devices. So that's really irreplaceable. For speech especially, these devices can't be tested on non-humans. So really, the patients are central completely to the development of the technology. As the technology becomes used outside of the laboratory, it will be important for the patients to work with developers of the technology to work toward making it easy to use and natural to use. One of the main difficulties with this sort of brain-computer interface is that they can be draining for the user, and somebody won't use a device that's, for very long at least, that's very difficult for them to control. So getting feedback from the users of this technology to help design systems that are more natural and more easy to use is going to be a very crucial aspect of the development process.
Very true. Kevin.
Hi, I see the patient really having a lot more opportunity to engage and participate in their active therapy and also in their home program. The patient is going to continue to be a central focus with client-centered practice, but some of these devices will be able to provide active assistance. So the home program and the program outside of therapy will be one that is potentially less frustrating for the patient, maybe more rewarding and more reasonable to engage in. The patient's still going to have to take a very active role in working with both the therapist and the actual device themselves. But I see the patient as playing a crucial role here in the use of this technology and for the advancement of their function.
I hear the term patient empowerment a lot now. Yeah, Terry.
Absolutely. I think we're dealing with a few different things. I think the technology we use cannot be too obtrusive. It has to be able to be easily integrated into one's life. If it's in the way or a nuisance, people aren't going to wear it or use it. The other thing is that the technology has to be easy to don and off or put on and off or to manage, to learn to work. It has to be simple, turn it on and off. How complicated is it? Which way does it have to go to put it on? That sort of thing has to be taken into consideration. But I think most of all from the patient, what we've learned is they have to value it. The information that you get from this device or from the technology, if you're measuring something, has to be valued by the patient. A lot of times researchers and clinicians get excited about this data, but yet, is the patient excited about the data? Or are we using the data in such a way that it benefits the patient in some way? So those things are very important, and we need to listen to the people that we're asking to wear these devices or to implement a particular treatment and get their input and feedback as to how we can do a better job. How would they really integrate this into their day-to-day life?
So would it be fair to say that the patient is moving from being a passive recipient of this technology to being an active consumer of this technology?
Absolutely. I think I see the patient as central, as captain of the team, driving the direction of things and really giving critical input on, how to really integrate technology in a very useful, way, into day-to-day life.
Yeah, Kevin. So this is sort of, it comes back to what Frank was just talking about, where the difference between communicating and not communicating depends on whether or not they have access to that technology. So this is really, really important. Another question I was going to ask Kevin and Terry is, what are the drawbacks and challenges of the technology? Are there situations where technology can do more harm than be beneficial? Can you think of situations?
Yeah, there are definitely some potential drawbacks. There is some commentary recently released in the literature talking about the cost-benefit analyses of some of these interventions. They're finding that using rehabilitation robotics and high technology in rehab is resulting in similar outcomes to doing the same case and dose-related interventions with the regular therapist or with an actual person. I think this is something that will probably change over time as technologies are improved and a little bit more readily available and costs start going down. But also the cost benefit is definitely something to take into consideration. Another thing, just like Terry mentioned before, is the user interface. Is the technology going to be easy enough to use for our patient, family member, or their support system at home? Does the person have experience using similar technology? And then there's always the unknown portion. Technology does have a tendency on occasion to fail. So will there be a way to recover or to find another plan in the event of technology failure?
I think that the patient, well, there's multiple issues, I think. One of them is that we've in a lot of these sensors that we use, for example, we can collect second-to-second data about people's day-to-day life, how much they're moving, how much they're sitting, how much they stand, how many stairs they climb, for example, how much time they have dyskinesia or tremor. But how do we actually use that data? If you're collecting this second-to-second, hour by hour, day after day after day after day, who's interpreting this data? Who's looking through this data? Who's making sense of the data? And is it being used in such a way that it can actually help the patient in their daily life? So I think we still have some barriers to overcome with both user interface, so we can, if a patient comes in to see a provider, a physical therapist, a speech language pathologist, a neurologist, and they've been wearing some device, and the clinician, if they go to take it, well, what are they going to do with all this data? How long does it take to look at? Can they look at it in a quick way to do something about it, or can it be remotely sent to them ahead of time? But even if that happens, can they look at it in a relatively easy fashion? There's so much information coming into this. How do we consolidate it down to a few key parameters that a clinician or a patient can digest and do something about?
Data mining.
Data mining, yes.
So this is our last question, and this is for all three of you. If you were to fast forward 20 years from now, what do you think the future of rehabilitation is going to be in your field? Let's start with you, Frank.
Okay. Well, 20 years is about the time frame I think it will take for these technologies to move from the laboratory out into the real world. So currently development is aimed at systems that are wireless, for example, so that there is nothing coming out of the brain, out of the head. This makes the system much better for the patient, both aesthetically and also in terms of avoiding infections which can occur with this sort of device. So much of the work between now and then is aimed at really making these things incredibly safe and durable so that they'll last for many years. The technology capabilities have largely been proven already with demonstrations in the laboratory. And these capabilities will, I think, profoundly change lives for people with locked-in syndrome in particular, where the technology offers the promise of not only giving them communication abilities so that they can communicate their needs to their caretakers and they can have much more meaningful interactions with their family and friends, but also the technologies will allow them mobility, the control of mobile wheelchairs, for example, the ability to use a robotic arm. It really, in 20 years, I think we'll see some amazing things where people are really becoming part cyborg, where they're in fact controlling external devices largely just through brain signals. So I think it'll have a huge impact on people with locked-in syndrome and people who are profoundly paralyzed in general.
Sounds exciting. Kevin?
Yeah, it is exciting. 20 years from now, I believe that we will see further development of the technology. We will see devices and robotic devices that are more reliable, that are easier and less costly to purchase, that are have greater production quality, that are easier to don, doff, and operate, and are a little more familiar to both therapists and both to patients. I also think there might be a little bit of input from both of the other panelists here today, both with some feedback and be able to communicate feedback about participation and about performance back to the therapist, who can then evaluate the data and adapt the therapeutic program for the patient remotely in between the in-person therapy sessions. And finally, I think that these device developers might be able to integrate a little bit more of what's been learned from the virtual reality and gaming industry to try to create some user interfaces that are engaging, that are motivating, and use some of the data from those areas to try to create devices and create intervention opportunities for people that they will want to participate in and that will keep them sustaining their participation in throughout their therapy program, so they can optimize their outcomes and optimize their function and improvement after a life-changing event.
I see in the future, the sort of sensors or measuring devices being very small. Maybe you could wear one sensor. Maybe it's just a skin patch, instead of something big that goes around your belt, for example. And I think we'll be able to collect the kinds of data we want, but it'll be delivered remotely in a wireless fashion, and we'll be able to look at this data and do something with it. I think we'll have ways to consolidate the data in a meaningful way. If a patient has a problem, for example, at home, they might be able to call their physical therapist or their physician and talk about the problem, and then that provider will be able to just go online, look at their data, look at the output, and do something, make a decision right there in the moment that can make a difference for that patient.
All right, we'll stop there. Thank you very much for all your really important insights, and thank you all for joining us.